Hello everyone, welcome to my channel Aptitude Club, and in this video we are going to discuss this important question, very interesting question on remainders. Now remainders belong to the numbers section of quantitative aptitude, and I have done a complete series on the entire concept of remainders. I'll pin it in the I section of the video. You can watch out if you want to learn remainders from the beginning. Do watch out the entire playlist, all the theorems and all possible types of questions based on remainders. Now let's try and see this question and how this can be solved and approached. I'll discuss it in two ways, how we can solve this. I'll give you two methods of solving. But before we start, I would request all of you to pause at this moment and try this question yourself and then look at the explanation later. Okay. So what is being given? Find the remainder when 7 to the power 344 is divided by 9. So method 1 is we'll follow Euler's Totient method. What is Euler's Totient method? So if I have been given the divisor 9, I'll prime factorize it as 3 square. Then I'll find its Euler's number, phi of 9. So it can be calculated in this way, 9 whole into 1 minus 1 by 3. So which is 9 into 2 by 3. I get it as 6. Now let me put it in this way, like in general, if any number is given, for any number, if the divisor is given, the first step is to prime factorize a to the power p into b to the power q into c to the power r and so on. Prime factorize the number. And once you have prime factorized, then you can easily calculate phi of n, Euler's number or Euler's Totient function also we call this, as n whole into 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c and so on. You selectively exclude the numbers that divide n so that you will be left with numbers that are co-prime to n. So Euler's Totient function, the meaning is number of natural numbers that are less than and co-prime to n. So we can use this formula. So that is what we did here. So the first step is to calculate what is phi of 9. And once you have done this, this is pure theorem based. Second method will be without the theorem. Then as per the theorem, it is said that the remainder of a to the power phi of n divided by n is 1. So we'll try and use that. So we have been asked to calculate remainder of 7 to the power 344. 7 to the power 344 when divided by 9. And using this theorem, we got the result that remainder of 7 to the power 6 when divided by 9 will be 1. So I'll break it in this way. This will be 7 to the power 6 into 7 to the power 6 into 7 to the power 6 and so on. It will continue. How many times can I take this? So 6 plus 6 plus 6, if I look at 344 and I divide it by 6. So 6 5s are 30, 44, 6 7 42 and the remainder is 2. So you can take this 57 times and be left with finally 2. So I'll be left with 7 to the power 2 and this has been taken 57 times. This divided by 9. Here you have taken it 57 times. And in each of these cases, the remainder will be 1. Like 7 to the power 6 divided by 9, the remainder is 1. Again 7 to the power 6 divided by 9, remainder is 1. So either it is 6 or any multiple of 6, you keep taking that and you will get remainder 1. So basically this bigger power just reduces to only 7 to the power 2. The rest of the power 342 doesn't matter. The remainder becomes anyways 1. So I'm left with remainder of 7 square divided by 9, which is remainder of 49 divided by 9, and that is 4. This is my answer. We're using the multiplicative property of remainders, that the remainder of a product is the product of remainders. This also I have discussed in a theorem. The remainder of a product is equal to the product of remainders. I'm writing it here. Do refer to the entire remainders playlist. You will understand this very easily. The remainder of a product is the product of remainders. So this is method 1 of solving, where we are using Euler's Totient function, and you can do it for any divisor, any composite number, or let's say prime number. Prime number, say we get the special case of Fermat's little theorem. But anyways, given any general number, find its Euler's Totient function, and the number to the power a to the power phi n divided by n, remainder is 1. We can use this principle and then extrapolate depending on what power we have to solve. Now this is method 1, where we need to know the theorem. But what if you don't know the theorem? Can the question still be solved? Answer is yes. How do you solve if you don't know the theorem? In that case, it is method 2. We are supposed to calculate remainder of 7 to the power 344 when divided by 9. What you do is think of a power of 7, okay, when divided by 9. Any power of 7 when divided by 9, it should give you a remainder of either +1 or -1. Can it give you? Or when does it give you? That is what you need to figure out. So 7 to the power 1 divided by 9, the remainder is 7. 7 square divided by 9, the remainder is 4. If I am taking 7 cube divided by 9, I am seeing that the remainder will be 1. 343, this is 343 divided by 9. 343 when you divide it by 9, 9 3 is 27, and then 63, 9 7 is 63. So 7 to the power 3 is giving me remainder 1, so I'll use that. So what I'll do is, I'll write it as 7 to the power 3 to the power 3131 into 7 to the power 2 divided by 9. Why am I using 7 to the power 3? Because every time you have a 7 to the power 3, the remainder is basically 1, and 7 square divided by 9, remainder is 4. So you get this, that okay, it is 1 to the power 114 into 4, or basically 1 into 4, answer is 4. No theorem. This can also be applied a lot of times in questions. I'm not saying in every question this is doable, but sometimes if you have simpler numbers, you should think in this way. Without the theorem also we can do. But yeah, the primary theorem, remainder of a product is product of remainders, that is essentially used in all questions. We call it as basic remainder theorem, but this question can be approached in two ways. Okay, if this kind of a question comes in the exam, we should find it very easy to solve, and you can easily understand this. If you are new to remainders and you haven't solved any question prior to this, maybe you can find it a little challenging, but once you watch the entire remainders playlist that I have pinned in the I section, you will understand every question, even complex questions related to this. Okay, it won't be very difficult for you to understand, but it's a process. Okay, we'll have to begin somewhere and then gradually build upon it. Hope all of you understood these two methods and got an understanding of how to approach questions on remainders. If you are new to my channel and you have watched this video so far, do subscribe to the Aptitude Club channel and explore the videos on the channel. You'll definitely find it useful in your CAT preparation journey. I upload videos very regularly so that you find some content which will help you on your preparation related to CAT and other management entrance tests. We'll meet again very soon in yet another video. Till then, keep solving, keep studying. Thanks for watching the video. Bye bye.